So hello everyone, welcome to YouTube channel of DCC and NIT-A. Now we will be solving the problem C, contrast value of educational code forces round 148. So in this problem, we are given an array A and its contrast value of the array will be the absolute value of the difference of the adjacent elements. So like if there are elements from 1 to n, then this will be its contrast value. So also it is given that contrast value of array of size 1 is 0. And now what we need to do, we have to build another array B in the same way like which is described. We can follow some conditions over here. We have to follow like B should not be empty and B is a subsequence of A. That means like we can delete some of the elements of A, but its order should remain the same, and that will be our the subsequence B, and the contrast value of B should be equal to the contrast value of the A. So these are all the three conditions to build the array B. So now we know that we need to have the contrast value of both the arrays same, and also now we have to find the minimum possible size of array B. So now we should be deleting some elements from B in order to reduce its size, because we need its minimum possible size. So now we need to say that if we delete some elements, it should not alter its contrast value. Like, let's see and some couple of sample cases which will give us the observation that which element could we delete and which we could not. So if we take some sample cases, like, let's take the sample case like the array of size 7 is given to us. There is this. This is the array. Now the absolute difference would be here. It will be 1, then here 2, then 1, 1, 0, 4. So these will be the absolute difference between the adjacent elements. Now the difference between 5 and 4 1, from 2 and 4 is 2, and then 2 and 1 is 1, and likewise for all. Now these are the contrast values. Now we can delete some of the elements. Like if I delete 4 and 2 and 1 from it, then what will be the array after that? This is the array A. Now, after relating some of the elements, I created an array B which would be looking somewhat like 5, 0, 4. This is B. Now, let's find its value, like contrast value. It will be 5. The difference between 0 and 5 is 5, and this is 4. Now, the contrast value is the sum of all of these. Now, it is 9, and it is also 9. So we can see over here that the contrast value remains the same even after relating some of the elements of A. So how I have related these elements? Like, there could be some approach, right? Let's see what is the observation over here. We can observe here that if we have any subsequence or the subarray which is decreasing or increasing, then we can just take the last two elements of that subarray. Like we can see here a subarray which is decreasing. So we can take only the first and last element of that subarray. Like why could we take that? Because if we consider the case of this subarray of 5, 4 and 2, now the difference between the adjacents will be 1 and 2. Now, after removing 4, what is happening? Like if I remove 4, then the difference will be taken from 5 and 2. Here, what is the difference? It will be 5 minus 4, that is 1, then 4 minus 2, that is 2, right? But uh, I can see the difference between 5 minus 2 is equal to 5 minus 4 plus 4 minus 2. Now, why is this happening? Because it is decreasing, right? It is decreasing. It will be only true if it will be decreasing. Even if there is a 1, then also it will be true. like the difference between 2 and 1, it will be 1, and like the first and the last element are 1 and 5. So now I will add 1 to it. Yes, that is actually the pairs. It is the value. It is the value. And for 2 and 1, the value would be 2 minus 1. So the sum of all of these will be equal to the difference of this, right? So this is happening because it is decreasing. It will be same even if it is increasing, because removing an element from it, it will not alter the actually the differences. So here we just need to find the difference. Like first we need to take the first value. For solving this problem, what we can do, we can take the first value, and then we need to find a number. Uh, like we can, if we have a number that is 4, like before it there is 5 which is greater than it, and next to it there is a number which is smaller than it, that means it is increasing. So there's no need of taking this to 4. Then I will move to this number 2. Now for this number 2, I can see, like, if I want to take, should I take this number 2 or not, right? If I take this number 2, then it will be the same as before only. But if I not take it, then uh, the difference will be 5 minus 1, and it will be same we have discussed over here. So that is what we have to do over here. Like first we will take, what will be the algorithm, like we will take the first element, then for the next element we will see whether it will be increasing or decreasing, right? If it is not increasing or not decreasing, then we will take that element that is for 0. Now for this 0, I can see the number before it, it is greater, and the number next to it, it is also greater. So we have to take this number 4. And now for this 4, we know that this is the last element. There is no number next to it. So there is no number which is greater or smaller than it. So we need to take this 4. So if we take this 4, now this will be our subarray or the subsequence B. Okay, so let's take another sample case. If it is 4, this is the triple case we can see. Like if you want to take one, like for every next one, we have an option. We can take it, either we can not take it. Like we can see here that there is the last one. Like we have to take it because this is the last one of this array, so we need to take it. But we can also see over here that if we take this one, it will not create any difference, because both of these numbers are since the same. So the, like, the difference will be 0, and this will only happen in the case when all the elements are equal. If all the elements are equal, then the difference will be 0 in the starting as well as at the end. So only one element will be remaining in the array. And also in the question it was provided that the contrast value of the array of size of 1 is 0. So we will try to have the minimum size subarray, and it will be of size 1. So its size is 1, yeah, and its contrast value is 0. So that is how we will be solving the problem. So this is the whole approach, like how we can solve this problem. We can also consider this sample case. For this, the answer will be 2. Why? Because this whole subarray is increasing. We can remove the elements between these 1 and 7. So the answer will be 2. At last, we will be having 1 and 7 as the two numbers that will be remaining afterwards. So I hope this approach is pretty much clear to you. If not, then you can rewind this video and watch it again. I hope that it will be clear after some time. So that's all about the video. If you have any doubt, you can comment on the comment section. And that's all. Yeah, thank you. Bye bye.